A set in mathematics, this is a set right here. A set is like a collection of items. Doesn't have to be just numbers. We're in this set A, where it's a collection of different types of fruits. Okay, we separate each element of the set by a comma. So apple is an element of set A. A pear, it's like in the group of A. Banana, that's like on team A. It's on group A. And B is a little bit different. B has two of the same elements as A, but it has just some less. It has a smaller amount of fruits. B has apple and banana in it, but it doesn't have pear, it doesn't have orange. Same thing with C. C has pear and orange, but it doesn't have apple, doesn't have banana. So which of the following are true? This notation here means it's a subset. In other words, that means B is a smaller part of set C. Now, is that true? The elements of B, actually, they don't correspond at all with the elements of C. So B is not a subset because its elements aren't in the element C. You can think of it like this. This notation says that this is the parent set and that all the elements here belong in the parent set. All the elements of B belong in the element C. And that's not true because apple, banana, neither of those are in C. But if you look at this one, wait, this one's not true either. A is an element. A is a subset of C. That means that all of A's elements are a part of set C. That's not true. Apple is an element of A, but it's not an element of C. So this one is like the parent. This is the one where you're supposed to be gathering the elements from. So that's not true. How about B? This says B is a subset of A. That means all the elements of B are a part of set A. That is true. Apple is a part of set A. Banana is a part of set A. So this is true. This says C is a subset of B. That means all the elements of C are a part of the subset B. Look, pear is an element of C, but that's not an element in set B, so that's not true. There's only one that's true for this one. So just one quick note about these problems. They're multiple select. Here, I'll show you. This is just another student's work. I just covered up the answers. Look, if there's the square boxes like this one and this one, that means it's multiple select. You select all that are true. Okay. Let me cover that up so it's not distracting us. So I won't do it now. Okay, here let's. There, we'll go through each one. It looks like this student chose one that was correct, but there was another one that's also correct because it's multiple select. Okay, so set A has 2, 3, 4, and 6 as elements. B has 2 and 6. C has 2, 6, and 7. So is A a subset of B? Definitely not, right? This set has to be bigger or equal to this set for it to be a subset. That means all of A is contained within B, and that's not true. 2 is a part of, okay, well that one, they both have 2. But 3 is a part of A, and that's not contained within B. 3 is not an option in B, so that A is not a subset of B. Is B a subset of A? That means all the elements of B have to exist in A. So 2 exists in A, that's good. 6 also exists. This is true. B is a subset of A. Is A a subset of C? So all the elements of A need to be in C for that to be true. Okay, so 2 is in there. That's good. 3 is not in there, so we can stop right there. A is not a subset. All of A's elements aren't in set C. Are all of C's elements in set A? 2 is in A. 6 is in A, but 7 isn't in A, so it's right there. We can stop because it's missing, like C has a 7 as an element, A is missing the number C. Is B a subset of C? 2 is in C, 6 is in C, so yes, B is a subset of C. Is C a subset of B? That means are all the elements of C inside the element B? Well, 2 is, 6 is, but we're missing a 7. So 7 isn't in B, therefore C is not a subset. It's not a smaller part of B.